Yeah, so today I joined with Wilson, who is also an engineer working on Cloud Composer. So both of us actually on behalf of the Intel Cloud Composer team will talk about, after operating Composer for some time, some of the lessons or more like a wish list we have heard from customers and see how we can share those kind of insights with the community and see what are some of the possible ideas, how we can make Airflow performant, secure, and simple. Awesome.
Cool. Yeah. Hi, I'm Wilson. I'm filling in for our PM, James Malone, who couldn't make it today. He's a little under the weather. So yeah, I'm going to spend about 10 minutes talking about kind of the problem statement of what experiences we've had setting out Cloud Composer to our customers and what their experiences have been in using it. And then Feng will follow up with kind of some more concrete ideas for how this might be accomplished. So since all of you might not know what Cloud Composer is, we'll start by looking at that mission statement that Aparva showed you earlier. I've bolded a couple words here, easy and portable, and just kind of want to drill down into what those actually mean for us. Easy means it's easy to write these workflows. We want it to not be, or want it to be accessible to all users who are interested in this, not just those who have software engineering backgrounds. We wanted to make sure that it was easy to get these, to do easy things. Like if you want a simple thing that can be replaced with a script and a cron tab, sure, you can do it. But it also needs to be possible and as easy as possible to do hard things, complicated things with your workflows. And lastly, we want to make sure that it's easy to actually deploy these workflows out and get all the infrastructure in place and support these workflows in production settings. I've also bolded portable. Portable means there's no worry about lock-in. It's if you want to take your workflows and run to some other cloud or take everything on-prem, it's easy to do that. It also means that if you develop these things out of, before you got to Google Cloud, it's easy to bring them into Google Cloud. So spoiler alert, the way that we did this is with Apache Airflow. As hopefully all of you are aware, it's a top-level project in Apache, in ASF, and has been growing very quickly. This is, of course, why we, one of the reasons we chose to base Cloud Composer on it. For those of you who, actually, let me get a show of hands. How many of you consider yourselves Airflow users? Let me do the opposite. How many of you don't consider yourself an Airflow user? Okay, cool. So we have some people to talk to for this slide. In Apache Airflow, workflows are defined as a directed acyclic graph of tasks, of things that need to happen, and you're able to specify dependencies between them. These are commonly referred to as DAGs and are written as code in Python. Rather than, as opposed to some other orchestration frameworks where you might write an XML file or some other configuration-based language like YAML. So with that high-level overview of Airflow out of the way, I want to talk about how we found Cloud Composer to be useful for our customers. One of the things that Cloud Composer builds upon just vanilla Apache Airflow is that it provides end-to-end GCP integration by having a ton of connectors that allow a large and growing set of connectors to orchestrate tasks in a Google Cloud Platform. And in addition to that, we put a lot of investment into making sure that Cloud Composer is useful not only for orchestrating tasks on GCP, but also for hybrid and multi-cloud environments. This comes from contributions that we've worked on to improve the operators that Airflow has, and of course Airflow already has a lot of operators for on-prem resources like SQL databases and all sorts of relational database management systems. One of the big benefits of using Cloud Composer over vanilla Airflow is the managed aspect. So Composer is a managed Apache Airflow service. So one of the big things is we streamline your operational tasks, so that it's very easy to install PyPy dependencies that are available to all your workers. It's very easy to distribute your DAG files to all of your workers and your scheduler, and so forth. We also offer upgrades to the latest Airflow versions, and we manage those and bring in old feature or new features, backport them into old versions of Airflow that you may not have until later. And at its core, like I said, Cloud Composer is based on Airflow. So if you want something in Cloud Composer, you are able to contribute that to upstream or to vanilla Airflow, and we'll pull it in and push it out to everybody who uses Composer. So how are people actually using Composer? Like I said, we have a rich set of GCP connectors, so people are able to do things directly on GCP, like bring up VMs, sort of DevOps tasks. They can also use it to do data analytics tasks. There are a ton of BigQuery operators. It's very easy to orchestrate BigQuery jobs using Cloud Composer. Cloud Composer also supports cross-cloud functionality. So using some of the existing operators in Airflow, you can do things like move data from AWS to Redshift across storage systems in different clouds like S3 and GCS. There are connectors for that. And then just for those of you who already use Airflow, there's no limitation on which operators you can stitch together. If you have an operator that moves something from AWS to GCP, you can work with it with GCP operators. Then once those are done, you can move that back to Azure or whatever else you want to use. We'll move on. So now I'm going to move on to sort of our wish list for kind of what our users have experienced. We like Perva mentioned, we've been Cloud Composer has been GA since July of last year, and we've received feedback from our users. A lot of them are very heavy Composer users with thousands of DAGs running at any given time. So some of the feedback we've heard is that in Airflow, today auto scaling is a bit of a pain, or just scaling in general is a bit of a pain. There's a lot that you need to do to configure your Airflow deployment to work for a large scale workload. There are a lot of knobs. You have to worry about your infrastructure. How many VMs do you have? How many cores do the VMs have? How much memory do they have? What's their I/O capability in terms of disk and networking? And then you have the issue of your database server. How big do you need to provision your database server? If you have 10,000 concurrent task instances, you don't want to overload your database server because everybody's writing to it all at the same time. And then beyond just the infrastructure, there's also the config piece. Where if you're using Celery Executor, which is how we do it in Cloud Composer, but I think the de facto standard for just distributed Airflow, you have to worry about how you're going to set all these different configs to manage parallelism, so you don't overload your Celery queue, so you don't overload your workers, and so that Celery is able to take full advantage of however many VMs and cores you have. All these things are coupled, and you have to tweak several knobs to actually get everything to work together well. And so some members of the Cloud Composer team are doing some investigation into what the maximum capacity of Cloud Composer is in terms of what its load, or in terms of the number of task instances and DAGs you can run concurrently. I'm going to share with you just some of the preliminary results from that work. So what we did, or what they did, was took 1,000 files with 100 DAGs dynamically generated in each file, and each DAG is a single task. Just run some basic bash operator, and they ran this on machines or different configurations. They tweak the knobs in different ways, and within a few iterations, we found that we can get 15 task instances completed in each second across those 100,000 DAGs using 8 machines with 64 cores each, and with a database machine with 8 cores. we don't need to look into all those detailed airflow configs. But I think one of the things to point out is, look, there are a lot of knobs here. And one of the things that Cloud Composer fortunately was able to make easier in running this investigation was you can see this nice graph on the right here. This is based on stack driver metrics that we export from our Composer environments. This makes it really easy to turn your knobs and figure out what the outcome of that experiment was. And I do want to point out that this 15 tasks per second is not necessarily an upper bound. This is after a little bit of experimentation, and hopefully we can get more, and we'll find a better way to get more. So to summarize that basically, I think there is some room in Airflow to make it easier to scale to large numbers of tasks. On the scheduler side, the scheduler is a bit of a bottleneck in many ways, one of which is scalability. You have a single scheduler. It's not a sanctioned activity to run more than one scheduler, although there are anecdotal reports of that being a successful strategy. So you have to have one scheduler process that's going to spin sub-processes to process however many DAGs you have. So if you have a million DAGs, you're not going to get back to DAG 1 until DAG 1 million has been processed. There's also the issue of conflicts. Since you're running one scheduler, it's running one Python interpreter. So if you have one DAG that relies on version A of one Python library, another DAG that relies on version B, you're going to have this incompatibility, this mismatch, and you can't parse both DAGs using the same scheduler process. And of course, single point of failure. So like I said, you can't run multiple schedulers or without voiding the warranty. So what do you do when your scheduler fails? Everything goes down. And DAG management is another issue with how Airflow is set up right now. Right now you need to basically have some distributed file system to make sure that you have your worker and scheduler see a consistent view of your DAGs. If there's some lag in how your distributed file system works, then you might get inconsistent views, and then you also need to maintain that network file system in some way. Furthermore, there's not really a good way of knowing that an uploaded DAG has been successfly committed and distributed, to every single worker and every single and the scheduler. One thing that's that would probably solve this would be Airflow already has a REST API that's experimental right now. What if there were some sort of API-based DAG management where you can say, here's a DAG, and then the API server says, okay, I've got your DAG. I guarantee that all the workers and the scheduler have that DAG. There's already there's already a trigger, but what about pausing, resuming, restarting? And how can we make this API have access control mechanisms on top of it? So another issue that we found with the way that DAGs are used in Airflow is that there's very little isolation. A malicious DAG has every single DAG that's in a particular Airflow deployment has access to all the database tables, all the database rows. It can go and mess with all the database state for any other DAG. The RBAC web UI, takes a step in the right direction, makes it a little bit harder for you to do this sort of mistake, with the web UI. But if you write your DAG code to do that, then you're still out of luck. Resource efficiency is an issue, especially for long-running tasks. The problem here is that if you have a 6-hour, for example, BigQuery job, and then you're going to have a worker thread that's going to sit there and poll for 6 hours, waiting for that BigQuery job to terminate. So that worker could be doing something else during that time. It could be running a bash operator. That's only going to take 6 seconds. Furthermore, the scheduler process is sitting there. If there's nothing to schedule, it's just sitting there burning CPU, spin waiting. Recently, Airflow introduced reschedulable sensors. So if the sensor runs out of time, it'll go into a idle, or it'll go back into the queue and can be rescheduled later, and we'll just resume polling rather than tying up a poll slot. I think in general, this idea from the reschedulable sensor could be generalized to any task, especially, of course, those that, like I mentioned, poll on long-running operations. This, of course, relies on the prerequisite that all tasks are idempotent, can be interrupted, and can be rescheduled. I think that's probably, to me personally, that's one of the biggest areas for improvement that we could have for Airflow. And so with that, Feng will come back and talk to you about concrete ways this could be improved.
Cool. Thanks a lot, Wilson.
So I just wanted to make a quick break. Food is here and drinks too. So yay. They're going to be setting up where the shrug was, and we move it to this side. So the good news is that maybe we can have a break after Feng's talk, or not?
That's after that. We'll probably done in 5 to 10 minutes.
Okay.
Yeah.
So after that talk, we can have a break so everybody can grab some food and we can resume the program. And the good news is that I did panic. So I ordered more food. So at 8, we're going to have a second round with some pizzas. So yay.
Cool. Great. So I'll try to move a bit faster so I don't stand between your way and the food. Like Wilson mentioned, really a lot of our users are enterprise customers. So in fact, many of them probably haven't heard of Airflow before. So it's kind of like the first experience for them to use Airflow. Those the various issues and wish lists we put up in the previous few slides are really like the feedback we have heard from our customers. Going back, we really want to say, instead of us trying to, fork and then make all this, hidden black box improvements into Airflow, we really want to say, whether we could give people a preview about, things we have in mind and various mechanisms we think how we can improve Airflow so that it kind of like support multi-tenancy. It becomes a lot easier for people to manage Airflow DAGs, and also it's kind of like secure. So the first thing we were thinking that might make a lot of sense is I really make a full-fledged API server. So this is like a high-level architecture diagram of how an ideal state we think an Airflow setup should look like. On the front end, you have Airflow API server service that is able to, there will be some corresponding authorization or authentication service that running along with the API service. And we try to make it in a way that, the only interaction you could possibly have with Airflow has to come through the API service. Beyond that, you just simply can't just say, gain secret access into the scheduler or executor or even to the Airflow DAG storage. The API service, on one hand, handles all the authentication and authorization. On the other hand, whenever, say, for example, if you submit a new workflows or new DAGs, those DAG code will be saved in some form of Airflow DAG storage. The community has been talking about this DAG fetcher abstraction for a long time. So what you could also build DAG fetcher, like some sort of access control into the DAG fetcher as well. So think about it, if we are going to be in this ideal state where we have a per DAG scheduler or executor, and then there will be a DAG fetcher process running alongside with the scheduler that tries to pull the corresponding DAG ID or DAG name. And then we'll have some access control, kind of like a setup ahead of time, so that only the DAG fetcher corresponds to the specific DAG would be able to have the needed permission to pull out the DAG code from the DAG storage. So that's basically sort of like a general idea we have in mind regarding how we think Airflow can be restructured a little bit to make it truly multi-tenancy. I'll come to details about things could contain in a per DAG scheduler or executor. But before that, I just want to give people some high-level overview on the set of APIs we have in mind. So of course, you want to have deploy, schedule, and management functionalities for your API, pretty much pertaining to CRUD operation on DAGs, and then also some additional, pausing, unpausing, resume, restart, and so on and so forth. And of course, like, monitoring, right? You want to be able to visualize the DAG execution, internal states, and whatnot. And finally, there's also the configuration. Well, ideally, because you want to make sure that for your, it's also often the case is a requirement that I only want a certain set of credentials to be available to one workflow or one DAG, but not the rest. So as you can imagine, for each workflow, there will also be some form of Airflow configurations, credentials, and variables. Diving on that idea a little bit more, we realize that, in fact, we might be able to introduce a new abstraction into Airflow, which is called context. If you think about it, all the things that you need to run your a DAG, in addition to the DAG source code, there are things like environment variables, Airflow configs, the secrets. So those are the things that are necessary for you to either instantiate your DAG in case you have like a dynamic DAGs, or they are the parameters that you rely on when you invoke or execute your DAG. As I mentioned earlier, we could implement in a way that each workflow is going to have a set of like such configuration data. But realizing that in an enterprise setting, you may have a few workflows belong to the same department or same team, in which case they may share the same set of configs. That's why we're trying to say whether we can introduce this abstraction called context that will try to encapsulate some DAG dependencies and have users being very flexible of deciding which particular DAG context you want to bind your workflow to. So here's a example. Imagine that you are in, you set up like two contexts. One is like really the dev context. The other one is the product context. It could be the case that from same DAG code in the development phase, you could bind them to the dev context. And once you're done with all this testing, verification, then you want to move your DAG to production setup, in which case, it's just as simple as just rebind it to another production context. So that's the way how we see it be easy to allow isolation among DAGs, but at the same time, also permit some form of sharing across all your DAGs. Of course, that's why earlier we mentioned that, Airflow Web UI RBAC is a great step towards providing some isolation. That comes at the UI, but it doesn't really sort of like propagate to the entire stack. So we're also looking for some form of a multi-tenant database to support end-to-end isolation. We try not to be very opinionated about which multi-tenancy database should you use. Rather, just any database that satisfies the requirement where you would be able to have reasonable resource or execution isolation so that a DAG will not hog the entire resources available in a database server. And of course, you want to make sure that it's also easy and cheap to create like a per DAG Airflow database. And there are also ways for you to easily configure icons so that, again, make sure that only the designated DAG scheduler or executor would have access to the per DAG Airflow database. This comes to the part where, how would you design a per DAG scheduler and executor? So we're thinking that maybe we should run something like a DAG-specific scheduler. Think about it, you have a scheduler that only runs a single DAG. And then in terms of executor, it's the same. I just want to mention that it's also possible so that you can, say, for example, extend and modify existing Airflow executors to support either autoscaling and isolation. Think about it in the celery queue, in the celery executor example, you can imagine that we can have each DAG has a dedicated queue, right? So that celery queue will be, again, will be processed by a specific worker. So this is a way for you to provide isolation among all your DAGs, but it could be very expensive. On the other hand, we have Kubernetes executor, and Kubernetes has been providing a lot of good isolation mechanisms as of today. For example, you can have maybe you can have namespace boundary for DAG isolation. We realize that both would require a non-trivial amount of engineering work, of course, to make sure today's Airflow would be able to work, those two executors will be able to support autoscaling and isolation. But it's also kind of operation effort. There's a lot of setup, not of operation overhead to get things right. Thinking about it, there are upcoming work or ongoing work that's specifically designed to handle isolation, handle auto-scaling. So we are essentially trying to think about whether we could introduce things like a Knative executor. It's open source based, and Knative, again, it runs on top of Kubernetes, but its specific goal is to take care of isolation and auto-scaling. This is not to say that if you run a Knative setup, it's not to say that you are free from no configuration at all or no VM setup. It just basically means that we would have someone Knative abstracts out a lot of the detailed complexity of doing all this auto scaling, expanding containers to run your task, so that at least at the Airflow layer you don't have to worry about how did you get the resource provision right. And interesting, Knative is also being open source, so it's also kind of flexible. Same interface, but you can run it either on-prem. If you so just run cloud, there's also for example, like a GCP native provision for running Knative applications. So with that, I'll try to wrap up the talk with a quick demo. Again, this is super early, so I'm trying to lower the expectation on the things you would say. So what we're trying to implement here is we try to come out with a customized executor. We could name can be changed in the future, but right now we call it a Knative executor, and then we use Cloud Run as the backend. So while waiting for this to be loaded, I think that's just give people some quick idea about the simple example we try to show here. We have this is actually taken out from the tutorial example from Airflow. But we instantiate that with 100 tasks. So rather than running a single task, we run now 100 tasks together with some, for example, after the print date, we're going to run concurrent 100 tasks. That's why I'm saying a lot of things can be optimized, but even with a very feeling more like a prototype or proof of concept thing, we would be able to get 100 tasks done in about 2 minutes, 57 and 59. So this is definitely a lot better than the performance you would otherwise guide on, say, a series setup. With that, I'm going to end the talk and see whether there are any questions from the audience. Knative is a serverless function effort from Google. It's open source. It has about it's kind of like think about how would you run serverless functions in open source. So that's what Knative is. Yeah, it's already open source. You can search and find on GitHub. The managed version in Google Cloud is called Cloud Run. That one is also the same API interface. It's just the case that the execution backend now takes care of all the resource provision. Yep. Cool. Oh yeah, sorry. Missed that.
So a lot of the improvements that you were talking about, contexts, scaling and everything, are these going to be like Cloud Composer specific features, or are you guys contributing this upstream to the Airflow?
Yeah, so we want to contribute back. Definitely want to contribute back to the community. Yeah, that's why, as I mentioned earlier, we want to give folks a bit preview. So that we can also get some feedback in terms of how do you feel about does that sound the right direction, not only for Composer, but we pretty much want to make sure that whatever concept we introduce not only work for Composer but also work for Airflow as well. Yeah. Yes.
As you said, in terms of scalability, you will have separate queue for each DAG, separate namespace for each DAG. I mean, that will be if we have 1,000 DAGs, it will be
Exactly. Yeah. So that's why I'm saying that then probably there will be a scalability limit which you will hit if you're using either serial or Kubernetes executor. Both would have some namespace. Like for Scenery or Kubernetes, there might be some upper bound you will hit. That's why we are really looking at other forms of isolation. Essentially, really comes down to if you look at a bit more on Knative. each service deployed on Knative is supposed to have perfect isolation across among all the other services deployed at the same time. So that's why we really leverage the additional mechanisms Knative put into their implementation to provide that kind of access isolation. Yeah.
Do you want to reload the demo? Because take time.
Oh.
Code restart.
Sure. There we go. I can try to create one while we're talking through this. Yeah, so or we can come back this and, it's probably going to take like 2 or 3 minutes to get everything done. Yeah. You have a question? Yes.
Along the same line. So the isolation that you mentioned was you had one of the slides you mentioned about one of the bottlenecks where the libraries are contributing. I'm trying to keep the isolation through like an operator or slightly different.
Oh, so the way we intend to achieve isolation is really see whether it's possible to run the scheduler and executor all with the same identity, and then run in a computing environment that is secure and isolated from other concurrent, like virtual computing load running on the same infrastructure. And let's say, for example, in the case of Cloud Run, you would be able to deploy multiple services on Cloud Run. And then there's perfect isolation among the two in terms of like CPU resources and also data or other forms of access. Yeah. All right, if not, enjoy your dinner.